Example 1. Sketch the curve. Sketch the curve given by each pair of parametric equations over the given interval. X equals t square plus 5 and y equals t upon 2 plus 4, where t lies between minus 4 and plus 4. Step 1. Make a table of values for t between minus 4 and plus 4. So here is our table with the t values ranging from minus 4 to plus 4. The corresponding x values and the y values. Whichever value of t we take, suppose minus 4, substitute here in x to get the value of x. Substitute the t here in the y to get the value of the y. So here are the values of the x corresponding values of y. Step 2. Plot the xy coordinates of each t value and connect the points to form a smooth curve. This is the curve. Also, give arrows in the curve to show the orientation of the curve from t minus 4 to t plus 4. So from t minus 4, the arrows point towards the t which is equal to plus 4. So this is the orientation or the direction in which the curve is moving. Example 2. Sketch the curve. Sketch the curve given by each pair of parametric equations over the given interval. X equals t square upon 4 plus 5 and y equals t upon 4 plus 4, where t lies between minus 8 and plus 8. So the first step, we will make a table of all the values of t ranging from minus 8 to plus 8. So when t is minus 8, so x equals minus 8 the whole square upon 4 plus 5, which is equal to 21. And y equals minus 8 upon 4 plus 4, which is equal to 2. So we make the table with the values ranging from minus 8 to plus 8. So we select the values with the interval of 2. Now plot the xy coordinates for each t value and connect the points to form a smooth curve. So this is our curve with t ranging from minus 8 to plus 8. Give arrows to the curve to show the orientation of the curve from t equals minus 8 to plus 8. So this is the orientation of the curve. It's moving in this direction from t equals to minus 8 to t equals to 8. Student's task. X equals to 3t and y equals to root t plus 6, where t lies between 0 and 8. You can pause the video now. Once you finish solving, you can play the video to check your answers. Example 3. Now we see how to write the equation in rectangular form. Write x equals to minus 3t and y equals to t square plus 2 in rectangular form. The first step what we do here is we find the value of t from the equation x equals to minus 3t. So the value of t here will be minus 1 upon 3 times x. That value of t we substitute in this equation y equals t square plus 2. So we get y equals t square. T is minus 1 upon 3x the whole square plus 2. We solve further to get the equation y equals 1 upon 9x square plus 2. When we simplify, the parametric equation yields the parabola y equals 1 upon 9x square plus 2. Student's task. Write x equals t square minus 5 and y equals 4t in rectangular form. You can pause the video now. Once you finish solving, you can play the video again to check your answers. Example 4. Rectangular form with domain restrictions. So here the difference is we have to write it in the rectangular form, write the equation in rectangular form, but there will be some restrictions on the domain. Let's check. Write x equals 1 upon root t and y equals t plus 1 upon t in rectangular form. Then graph the equation, state any restrictions on the domain. So x equals 1 upon root t. X square equals 1 upon t. We have squared both the sides. After squaring both the sides, we get x square equals 1 upon t. Now t equals 1 upon x square. So here we've got the value of t, which we will substitute in the equation for y. So we get y equals t plus 1 upon t, which is equal to, substitute the value of t here, we get 1 upon x square plus 1 upon x square. Example 5. Rectangular form with domain restrictions. Write x equals to 1 upon root t and y equals to t plus 1 upon t in rectangular form. Then graph the equation. State any restrictions on the domain. Now, from this equation x is equal to 1 upon root t, we find the value of t. We solve this equation for t. First, we square both the sides. So, we get x square equals 1 upon t. Therefore, t will be equal to 1 upon x square. So, the value of t is 1 upon x square. This value of t will be substituted in the equation for y. So we get y equals x square plus 1 upon x square divided by 1 upon x square. Now we simplify the numerator. So we get y equals x square plus 1, as the denominator x square and this denominator x square will get cancelled. So we are left with y equals x square plus 1. While the rectangular equation is y equals x square plus 1, the curve is only defined for t greater than 0. The domain of the rectangular equation needs to be restricted to x greater than 0. Here is the graph. Example 6. Rectangular form with theta as parameter. Write x equals 2 cos theta and y equals 4 sin theta in rectangular form. Then graph the equation. First, we have the equation for x, which is equal to 2 cos theta. Cos theta will be equal to x upon 2 after rearranging. Now the equation for y, which is 4 sin theta. So after rearranging, we get sin theta equals y upon this 4. Now we know the Pythagorean identity, which is sin square theta plus cos square theta equals to 1. We substitute the value of sin theta and cos theta in the Pythagorean identity. So we get x upon 2 the whole square plus y upon 4 the whole square equals to 1. After solving further, we get x square upon 2 square is 4 plus y square upon 4 square is 16, which is equal to 1. So it's an ellipse. The curve is an ellipse and see the orientation is in this direction. Student's task. Write x equals 3 sin theta and y equals 8 cos theta in rectangular form. Then sketch the graph. You can pause the video now. Once you finish solving, you can play the video to check your answers. Example 8. Write parametric equation from graph. Use each parameter to write the parametric equations that can represent y equals x square minus 4. Then graph the equation, indicating the speed of orientation. T equals to x. When t equals to x, we get a parabola. The orientation is in the direction from t equals minus 3 to t equals plus 3. So this is the original equation we have. Here we have x is equal to t. So in the original equation we substitute x as t. So we get y equals t square minus 4. The parametric equations are x is equal to t and y equals t square minus 4. The associated speed and orientation are indicated on the graph. Example 9. Write parametric equation from graph. Use each parameter to write the parametric equation that can represent y equals x square minus 4. Then graph the equation indicating the speed of orientation. So we have t equals 4x plus 1. From the equation, we rearrange it to get the value of x. So we get x equals t minus 1 upon 4. Now we substitute the value of x in the original equation, which is y equals x square minus 4. So we get y equals t square upon 16 minus t upon 8 minus 63 upon 16. X equals to t minus 1 upon 4 and y equals to t square upon 16 minus t upon 8 minus 63 upon 16 are the parametric equations. Notice that the speed is much lower than in part A. Student's task. Use each parameter to write the parametric equations that can represent y equals to x square minus 4. Then graph the equation indicating the speed of orientation. Here we have t equals 1 minus x upon 4. You can pause the video now. Once you finish, you play the video to check your answers. Projectile motion. For an object launched at an angle theta with the horizontal at an initial velocity v0, where g is the gravitational constant, t is the time and h0 is the initial height. The horizontal distance can be given by x is equal to t v0 cos theta and the vertical position can be given by the equation y equals t v0 sin theta minus half of gt square plus h0. So this is the angle theta, this is the horizontal distance and this is the vertical position. Real world example, projectile motion, basketball. Khadija is practicing free throws for an upcoming basketball game. She releases the ball with an initial velocity of 24 feet per second at an angle of 53 degrees with the horizontal. The horizontal distance from the free throw line to the front rim of the basket is 13 feet. The vertical distance from the floor to the rim is 10 feet. The front of the rim is 2 feet from the background. That's the backboard. She releases the shot 4.75 feet from the ground. Does Khadija make the basket? Now, let us first make the diagram of the situation. If you see, Khadija is standing here. She released the ball from the distance of 4.75 feet from the ground. The initial velocity of the ball was 24 feet per second and the angle between the horizontal was 53 degrees. The rim was above the ground at 10 feet and the front of the rim was 2 feet from the backboard. Now, to determine whether she makes a shot, you need the horizontal distance the ball has travelled when the height of the ball is 10 feet. So, y equals tb naught sine theta minus half of gt square plus h naught. This is the parametric equation of vertical position. So, after substituting the values, we get v naught is 24. Theta is 53 degrees, G is 32, T square is written same, H naught, that's the initial height, is 4.75. So we substitute the values in the equation and graph the equation for vertical position and the line y equals 10. The curve will intersect the line in two places. The second intersection represents the ball as it is moving down towards the basket. This is the second intersection point. So the ball is moving down the basket from this point. The value is about 0.77 seconds. Determine the horizontal position of the ball at 0.77 seconds. So, x equals t v naught cos theta. This is the parametric equation for horizontal position. So, v naught is 24. The time t is 0.77 seconds. Theta is 53. So, we have substituted the values for v naught, theta and t. After solving, we get x is approximately equal to 11.1. Because the horizontal position is less than 13 feet, when the ball reaches 10 feet for the second time, the shot is short of the basket. Khadija does not make the free throw.